Hey everybody, welcome back. I'm Ryan Shrout, joined by my good buddy Tap.
Hello, hello.
And we're here with another ARC update for you. We're going to talk about a bunch of cool stuff, some performance, some science.
I love science.
Some science and some tools that you can go download and go play around with that stuff.
For the first time ever, we're going to kind of make the guts of how GPUs look and work more accessible to all of our gamers. So hopefully we're doing some good here today.
I'm excited. Let's
all right,
start.
so we're going to talk about three different things today. First of all, you know we've been working on our driver since launch. And today I'm happy to announce that we have re-architected our DX11 driver, and we've improved performance by around 20% across a collection of DX11 titles, which is a big change, a lot of effort, and the engineers have again knocked it out of the ballpark. So I'm very excited about that. The second thing I'm going to tell you about is a new way to think about graphics performance that I call a GPU Busy metric. And it helps you for the first time get a sense of, hey, am I GPU limited? Am I CPU limited? What should I do about the performance of my GPU?
That's the science part.
That's the science. It's pretty exciting. And the third thing I'm going to show you is our new tool that's called Intel PresentMon Beta. And what that thing does is it's an overlay that you can put in a window if you want, and it really digs into the characteristics of performance, telemetry, it's open source and multi-vendor. I'll tell you all about it.
And it looks cool too.
And it looks cool too. All right, digging in. So a quick recap. In the beginning of the year, we told you about how we had re-architected our DX9 driver, and we improved performance by about 43%. At the same time, we brought the price of ARC A750 down to $249, and it was amazing value.
Yeah.
Right? And also during that time, we showed you charts that look like this, where you see lots of performance improvement, and we said we're going to add this to all of our DX9 titles, and today I'm happy to announce that we are totally done with that transition. All DX9 titles are running on the new driver.
That's awesome to hear. So that's like we've kind of completed the one step.
Yep.
And now we're going to talk about
maybe we'll talk about another one. Yeah. Now at the end of Q2, we also talked about how to start thinking about the right way to build a PC for ARC A750. And the idea was you want to get the right GPU and CPU balance so that you don't pay too much for a CPU, you don't pay too much for a GPU, and you get them both working together evenly.
And this was the story. We brought tens of thousands of data points, more science into the
pages. Yeah. It was crazy.
And that all comes into play today as we go through data too.
Absolutely. And we also made available bundles that are still available. CPU, GPU bundle at $419 and systems starting at $799. So
crazy.
It's a crazy deals, especially in today with the prices where they are for GPUs. I'm delighted that Intel is working hard to change that. Right now, let's recap everything else we've done. Since launch, we've had 30 driver releases. I mean, 30 drivers is how we make our GPU better, and it's an incredible pace.
It is. It is. We've had 57 or more games supported through our Game On Driver program.
Wow.
This is making sure on day one that ARC users have the best possible experience they can on that platform.
It's a huge effort, and I appreciate all the end-to-end testing for that. We've also had over 70 XeSS games enabled, which is our AI-based technology that renders at low resolution and then uses an AI network to scale it up to get great results, and it improves performance. And the fact that our DevRel and DevTech team have gotten integrated in over 70 titles, it's an amazing result. So I'm very happy. But that's not it. Since then, we also have been continuously working on our driver.
That's what those 30 releases do.
A labor of love forever. I've said that before, right? And today we're happy to talk about DX11, right? We have huge improvements in DX11. I already mentioned it's up to 19%. This is showing the individual data points for each of the games. But think about it as, we're just beginning DX11. There's going to be more games added over time. Right. If you normalize this data, you can see the scaling is between 5 and 30%. And again, your mileage will vary. This is showing 1080p normalized. So the net is that our performance benefit for DX11 is continuing to improve.
Yep, and this is like we started on DX9, the beginning, right? Yep. A subset of games that are important. We'll talk about it in a minute.
Yep.
Right, and got your average frame rates and your 99th for your smoothness metrics.
Yeah. Now let's show the 99th data. It's not just about average, but having the games get smoother is also equally important. Many of you guys know that we care about this. It shows gains between 10% and 50%, and it's just amazing. Now the reason we care about this, Ryan, as you know, is because DX11 is huge. It's everywhere. Over 1 million players are playing Counter-Strike today concurrently on Steam.
Yeah, it's a lot, right? And if you look at games like Valorant, Overwatch 2, even GTA, right? You still got hundreds of thousands of people playing these games. It's important that we have the best experience that we can give them.
Absolutely, and there's no way we're ever going to slow down, right? More and more DX11 titles are going to get added, and sometime soon we hope to complete a complete transition to the new driver architecture.
Right.
The summary is, We've improved performance by around 19% for DX11 titles that are supported, and we've improved smoothness by about 20%. Now, one thing I have not mentioned yet, which is kind of interesting, is all of the data I've shared so far is with Core i5.
That's right, using one of our balanced builds configurations.
Yeah, now Core i5 is a better price point to A750, better, more natural match.
Sure.
But it has different ways that you would optimize the driver, different ways you'll see performance. But I do get a lot of questions about, well, what's this look like with Core i9?
Of course.
So here you go, Core i9 data. What you'll see here is that you do see scaling on DX11 for Core i9, but it's different numbers. And it's different because Core i9 is starting from a higher frame rate because it was able to absorb some of the CPU overhead that was present in our prior driver. So you're not going to see as much benefit on Core i9 with the new driver. And this chart says that, right? It says that with the new driver on Core i5, you get 19% performance improvement. But on Core i9, you get 12%. And that's a little bit hard to understand.
But it's still a good uplift, but it's curious, why is it less on the higher end CPU than on the
You're
Core
exactly
i5?
right? And it all goes back to the idea that the higher performance CPU was able to absorb some of the inefficiencies that were present in the driver on prior releases, right? But that's what we're going to do. We're going to dig into the science of what the heck's going on there, right?
The science starts now.
The science starts now. All right, so everybody has seen charts like this before. This is a frame time chart, and it's how we all look at performance now. You remember from back in the day.
Yes,
kind of
way back in the day.
And so in this case, it's kind of the inverse of frames per second. So higher is less good. And so I think we're running between 5 and 10. So it's like 130 frames per second on average. But you can see it's a little spiky and it's a little bit wide. So this is not like a perfect experience. This is showing our launch driver with Core i5. And we clearly had work to do. This is DX11, Overwatch 2, 1080p Ultra.
Okay.
Now, the question is, what's happening here? So I want to go to that next click down and explain what you see, okay? This is a view of how the render pipeline works on a game. First, the CPU does stuff. And in this blue section, the CPU has game logic that's doing things like physics, it's doing AI for the characters, it's managing resources. But once the game has sort of updated its game state, look at the mouse and the keyboard and all that stuff, then it does what's called render. And on the CPU side, render means you're converting from game state to DX commands that are sort of like graphical states. So think of it as, instead of having a character, you're going to convert that to like draw these triangles, use these vertices, use these textures, and that's what render does. It communicates between a game state and a graphic state through DX.
Got it.
Okay, now DX, when you get to this thing that says present, that's when the game tells DirectX, I've sent you everything you need. Please go ahead and draw that picture.
Right.
And the game is just completely oblivious to what happens after it says present. It's just going to wait, and that's what's happening. The game is waiting for present to complete, which DirectX is telling the game, I can take your next frame. And that's why the white stuff starts there, right?
Got it.
Now, the cool part is when we're measuring frame time, it's from the present of the blue frame until the present of the white frame. That's sort of like, how long did it take me to render? And we just do that over and over and over, and that's the way we do graphics performance measurement today.
Yeah.
Okay, but there's more going on here, Ryan.
It seems like it. We've only got the CPU highlighted. I bet something happens on the GPU.
Exactly.
Too, right?
So now in this middle layer, that's the GPU. All right, so once you call present, the driver starts getting involved. DirectX starts getting involved and takes those DirectX commands and converts it to a language that our GPU can execute natively. So think of that, we call that kind of a command list or command buffer, and it's like micro instructions that our GPU can process. Right. And then the GPU kicks off and it starts doing what's called a GPU render, and it's doing the mathematics to generate pixels. Okay, and at the end of the day, when the pixels are all done, it's called the duration of GPU render, and that's what I call GPU busy. Once it's done drawing the picture, we're going to do what's called flipping, and we're going to scan that onto the display. So this is the magic behind the curtain of how a game works, how graphics works. Don't go to college, kids. You can get it all here. No, do go to college, but at the end of the day, this is it.
But it's worth, this is I call this a simplified illustration.
Yeah.
Right? Because there's obviously a ton of other complexity in here. We simplified things, so it's like there's buffers and cues and other stuff.
If you're a graphics engineer, don't comment. Okay, don't put it in the comments. So there's clearly a lot more going on here. But what I want you to take away is there's two things that we could measure and that we're going to start measuring.
Right.
One is frame time, which is what we're used to measuring, and this new thing is GPU busy. And I hope already you can kind of see that if GPU busy is roughly the same length with frame time, then you're sort of balanced.
Yep.
If GPU busy is very short relative to frame time, you've got some problems and you've got some opportunities.
Yeah.
Okay? So let's come back to this picture. This is now that frame time thing again, only this time I'm going to add a new metric called GPU busy, and this is the yellow line you're going to see. So what's happening here in these two boxes is in the first box, the frame time is way longer than GPU busy, and that means that the CPU is pretty much gating the processing on the GPU. In the middle, you can see frame time and GPU busy are kind of the same, and that means you're more balanced, or maybe the GPU is limiting, but it's much more close to where you want to land. So that's good, right?
In that first highlight, there's like a 50% delta between GPU busy and frame time.
Yeah.
Right? Again, you called it opportunity to improve.
Get
right?
better.
To make performance better.
Get better, right?
Yeah.
Now, if you think about what's going on in my original picture, this is how to think about it. In the case on that first box where you're limited by the CPU, the render happened on the CPU and it sent stuff into DirectX and the driver, but for some reason it didn't land and start rendering in the GPU yet. That could have been because the driver's doing shader compiles, it's doing resource management, it's doing some kind of interlocks, could be network traffic, could be multi-threading stuff. There's lots of things that can make it stall out and like not get work to the GPU. So in these cases, you realize you have an opportunity because all this GPU power, all those billions of transistors are sitting there doing nothing. Okay, so let's come back to our picture. Here's frame time again, and now I'm going to show you the difference between frame time on our old driver and frame time on our new driver.
Yep.
There's old, here's new. Okay, and new, that light blue, you can see it's brought it down.
Yep.
Right? Now, we would have left the conversation there.
We would have looked at this and said the frame time is lower.
Yep.
That's good.
Yep.
The frame time is a tighter distribution.
Yes.
That's good.
Yep.
And we would have said, hey, we've done our work.
Yep.
Fantastic.
You guys are great. Now, I think that's fantastic, and the driver team would have been happy, and I would have been happy. But the truth is there's more that we can think about here. So I'm going to add a new piece of information. This is the new driver again, and now I'm going to show you GPU busy. So if you think about it, GPU busy with the new driver, it's right on top of each other.
Yep.
And what that's telling you is in that first box, we've recovered all that performance that we had left on the table, basically, because we had overhead in our driver. And in the middle, you can see the distribution's getting tighter even more than it was before. Yeah, so GPU busy is a nice way to get a sense of, am I balanced? Is there bottlenecks? What's going on? All right, now this is a picture of what that looks like when you're balanced. You can see the frame time length and the GPU busy are about the same length, and you're in generally a happy place. Now this is grossly simplified because there is a lot of queuing that's happening here, but just for simplicity perspective, I took it out.
Okay.
All right, so now we're going to dive in on GPU busy a little bit and look at some specific small time frames, right?
Yeah, no, it's a different game.
Different game.
We're going to show like a different kind of before and after. This is where I think having a metric like GPU busy allows reviewers, enthusiasts, whoever, to go look at a bunch of different types of scenarios.
I totally agree. This is actually showing you 1080p low on Counter-Strike 2. And the first thing you'll notice is that GPU busy is very low. It's like 2.5 milliseconds, so very little work on the GPU. And you can see the CPU kind of spiking up there with frame time. This means that your experience is not going to be super great and that your CPU is still limiting performance. But the truth is it's a very low render work, so there are going to be times.
It's a very high frame rate that's happening.
Very high frame rate, and so it's not surprising that your CPU is gating performance. Now, the next picture, I'm going to show you same game, same setup, but we're changing the settings from low to ultra. And in this case, you can see the workload of GPU busy went way up, and now the CPU doesn't have such a hard time keeping that GPU fed because the GPU is busy for a long period of time. Right? So it's a very cool way to start in real time, kind of visualizing, is my system performing optimally?
Right.
Okay. So that's a lot to digest.
It is. And you said real time. This isn't in real time.
This is a picture. This is PowerPoint. But you know what? There is a new tool that we're making available starting very soon. This is actually called Intel PresentMon. Now, Intel PresentMon Beta, yes.
Oh, wow. Look at that.
Yeah, look at that. The Intel PresentMon Beta is a tool that's going to be open source, multi-vendor, and it's going to be available this Friday.
Today.
Today, yes, as a matter of fact, today. Yeah, and what it does is it takes a piece of software that we've been doing for a long time. We launched something around 2017 that's a piece of software called PresentMon. And that PresentMon kernel basically is being used by lots of third parties. It's used by CapFrameX, it's used by FrameView, it's used by OCAT. And what we're doing for the first time is we're putting our own layer on top of it to make it available directly to end users.
Yeah, and this update makes it what I would consider user-friendly in any capacity, right? For reviewers and software developers, PresentMon has always been an amazing tool.
It has.
But now you can install it on your machine easily and start to look at that data in real time.
I know.
Not just at charts.
I know, it's a bit crazy, right? So it's got a configurable overlay with real-time graphing. We actually wrote our own mini renderer. So the graphs are very low overhead, and you can make them full screen, and they have very little impact on overall performance. It's multi-vendor, as I mentioned. It does include all the balance metrics. So GPU busy, you can see in real time. That is pretty delightful in itself. You can kind of look at, as the scene is happening, am I CPU limited, am I GPU limited? I mean, the conversation, I think, is going to really ramp up. Yeah, we support multi-vendor. I mentioned NVIDIA. We support AMD through their open APIs. So NVIDIA API, NVIDIA API, we do use to get NVIDIA telemetry. We use ADL to get AMD telemetry, and we're using our own IGCL. Thank you very much to get the Intel telemetry. It's going to be open, so we're posting all the source code on the GitHub repository that is PresentMon, and there's also going to be a download link on your website. Right. So it's super, super exciting. Also, for all the people that are using PresentMon today, we're not changing the legacy PresentMon API, so OCAT's not going to get messed up, FrameView's not going to mess up, everybody can do it. Now, I want to make a plug. It's open. We are open to feedback. Any of the other IHVs, NVIDIA, AMD, if you're listening and you want to make a submission, just do it on the open source tree, and we're not trying to make this proprietary in any sense.
What I think would be really cool to look at now is I want to see the visualizer in action.
All right, well, let's take a look at the demo. All right, guys, we're here with Intel PresentMon Beta, and up in the right-hand corner, you can see, we're listing just the GPU that we're running, the FPS. This is what we kind of call the basic display. It's showing you FPS, and it's also showing this cool real-time graph. I think I mentioned we wrote our own renderer to do really high-quality graphs with really low overhead, so you can have these things up and it doesn't affect performance. But this is what you might do when you're just, normal everyday gaming, right?
Yeah.
Now, with a hotkey, Alt-Shift-P, you can toggle through four different presets. This is showing you more of a GPU telemetry, kind of a GPU evaluation-centric view. We have FPS up on the top, average FPS, and then percentiles. So this is showing you the real-time percentile. You don't have to graph things anymore. And it's also showing you GPU busy, which we talked about earlier.
Exactly.
Right? So in real time, you can kind of say, how is my balance between my GPU and my CPU? In this case, the GPU is rendering somewhere between 4 and 8 milliseconds, and you can see the CPU is about another 2 milliseconds on top of it. So it's pretty close, but not quite perfectly optimized. Right. Now, coming down here, you can see frequency is kind of changing every once in a while. It's kind of going up and down, and as you come down, voltage and temperature and memory, it really gives you an easy view of how is my system performing.
And you get to decide, like, do I want all this information there all the time while I'm playing? Probably not.
Probably not.
There's maybe some geeks that really like it. You can adjust transparencies and everything as you go, but there's you can go customize all this. You can have as little or as much information as you want.
Let's go ahead and change to another one. This is more like a slightly simplified version, but I think the real power is how do I configure it, how do I play with this? So let's go ahead and jump to that. I'm going to pull up the PresentMon interface. Now, this is how you launch PresentMon. You can kind of, coming back to the top, you pick the process that you want to monitor, or you can enable auto-targeting, got a lot of hotkeys, and if you hit edit, you can actually configure that overlay. So in this case, we picked a bunch of stuff. We've got some percentiles, some averages.
Now there's a lot of words on this and fields.
So like everything from present mode, sync mode, lots of latency measurements, frequency measurements, telemetry. It goes on and on and on. One thing that's cool though is we also have a histogram. So if you pick GPU frequency, you say I would like to look at raw, and maybe now instead of a line, I'm going to say histogram.
Now what is raw versus average? Because that might be new to people.
It is. So if you think about PresentMon, now there's a collection of logic in there that's doing statistics calculations to calculate percentiles, for example. So we calculate average FPS, we calculate 99th and 90th and 95th, but some people really want to see the raw data, no manipulation, and that's what raw means.
So when you have average and 99th, you have little buckets that you're doing sampling from, right?
Exactly.
This is all of the data.
All of it right in the kit and caboodle. So down here, we're starting to generate a histogram of frequency. It's running between 600 and 2400. It's a little bit low, so let me go ahead and lower that bucket size. So we come over here. On every setup, you can click this little setting thing, and you can adjust how the number of bins work, how the buckets work.
Auto scale
count. So we're going to send this, auto scale the count, and now we're back here. And now you can see I'm getting this cool histogram that's in real time of my frequency as I'm playing my game. So come on.
It's pretty cool, and we've done a lot of playing around with this kind of stuff, looking at how frequency and utilization and how the histogram view can give you some interesting.
Yeah, and it's got a lot more configurability. If you come down here, go to the main section. There's a section up top here for settings, and this is where you adjust things like how big do I want it to be. You know, I like it to be big, and you can adjust the graphic scaling, which you know I like it to be big, and now we go down. You can make it more transparent. So this is like a little HUD on the whole screen. And if we go back, now you're starting to see, all right, I've got a bigger thing. It's doing real time. It's on top of my game. This is just cool to me. I don't know. I love this stuff.
It's really neat, and this is something that enthusiasts, gamers, reviewers can all use. Yep. You can capture data with it, obviously, all the performance information that you would want. But if you just kind of want to see what your system's behavior is in real time,
it's easy
this is
to
a really
see.
Cool tool.
And I think you're going to see us add to this over time. Start to get a better sense of what's gating my performance on my CPU, what's gating my performance on my GPU, and seeing it in real time on top of a game just makes it that much better.
Very cool. Let's go wrap things up.
Yep. It was cool, right?
We've got different points of view on how to make the overlay look good, but that's fine.
I could do that all day. I could do all day. I want a special shout out to Mark Galvin and Ray, who did a great job on that software. Really just appreciate all the work they put into it. And of course, Jefferson Montgomery, the original PresentMon author, so all good work. All right, so let's summarize. The big news is we're continuing to make our driver better, make ARC A750, A770 better. We improved performance this time by about 20%, 19% for DX11 titles that are supported, and we improved smoothness by about 20% by re-architecting the driver.
Very impressive changes.
I'm so excited.
Yeah.
Now, we've also done two other things. First, we introduced a new GPU Busy metric, which I think everybody gets now. It's kind of like, how balanced am I? And we have a brand new tool called Intel PresentMon Beta. It's available today. It's open source. Download it, try it, give us feedback. It's going to be great.
I'm really interested to see what the reviewers have to say about it, and when the community gets their hands on it, what they like about it. Like you said, we're soliciting feedback. We'll make it better, and we'll continue to iterate on the tool.
Absolutely. I'm excited.
Thanks, everybody, for joining us here. Make sure you check arc.intel.com for any other updates that we have, and we'll see you again soon.